So this is a video lesson on 7.5 and 7.6 trigonometric ratios. So the first thing we're going to do is identify the parts of a right triangle, and we're going to use the diagram here to the right to identify its parts. This would be triangle A, B, C. The parts of a right triangle are the three interior angles and the three sides that form that triangle. The first part they're looking for is the name of the hypotenuse. So we can identify the hypotenuse as the side that is opposite of the right angle of a right triangle. So that side would be this side located right here. The name of it is the vertices that are at the endpoints of that segment. So the name of the hypotenuse would be segment AB or BA. The name of the side opposite is our key word here, of angle A. So if I'm standing at angle A, that means I'm located at this vertex right here. And if I follow the two rays that form that angle, the side that would be opposite of angle A would be side BC. They also ask us to name the side adjacent to angle A that is not the hypotenuse. So if this side's the hypotenuse, the other adjacent ray that forms angle A would be this side named AC. The keywords that we want to focus in are opposite and adjacent, and we're all looking through our reference point at angle A. We know our hypotenuse, the name of our hypotenuse is AB, but what would the name be of the side opposite from angle B? Now we're standing at angle B. So if I'm standing here at B, vertex B of my triangle ABC, the side opposite, if I follow those two rays of my angle, takes me to side AC, which interestingly enough is the side that was adjacent to angle A of the other side. So when we look at angle A and we were looking at adjacent, that was AC. Now we're side opposite of B is the same value, AC. And then also when I'm looking at the adjacent of B, then I'm going to go ahead and stand at B, and the adjacent side, not the hypotenuse, would be BC, which is interesting enough the side opposite of angle A. The next thing they ask us to do is find the length of the hypotenuse. So go ahead and pause the video at this point and see if you can determine the method of which you would go through to find the length of the hypotenuse, meaning the distance from B to A. Go ahead and pause the video and see if you can find that measure. If you remember, to find the length of AB, you would need to use the Pythagorean theorem, which states that if I have the hypotenuse squared, its value would be equal to the leg squared plus the leg squared. So the two legs of the two sides adjacent to the right angle, so they would be 5 and 12. The hypotenuse is what I'm trying to find, the length of AB. When I square 5, I get 25. When I square 12, I get 144. And when I add those together, I end up with a value of 169. To find the length of AB, the only thing else I have to do is to undo a square by square rooting. The square root of 169 is 13, because 169 is a perfect square. Now, whenever we're trying to find angle measures, because our goal here eventually to use trigonometric ratios is to use angle measures. So whenever we're using to find missing angle measures, we'll use the variable theta. Theta is a Greek letter most commonly used for missing angle measures in trigonometry. So, sliding down here on our worksheet, we're going to go ahead and identify our formulas for trigonometry that use proportions and patterns to find side lengths. To find side lengths of a right triangle. By using trigonometry, which a lot of times you'll hear teachers call it trig for short. We use trigonometry, we will now be able to find angles as well. Trigonometry uses special ratios. Ratios we know are a quotient of two numbers. special ratios to convert side lengths into angle measures. Because these conversions work all the time, but only with right triangles, they work all the time for right triangles, each type of ratio has been given a special name. And the three special names are sine, cosine, and tangent. To help us remember these special names and the ratios that go with those names, we're going to come up with an acronym, or a set of letters that helps us remember a pattern. We're going to use an acronym to help remember this. Our acronym is spelled HOS, so, CA, C-A-H, TOA, T-O-A. So, ca, TOA. It might seem strange, but go ahead and say that out loud to yourself, just so you make sure you understand it, and also remember it. So, ca, TOA. The acronym SOHCAHTOA will help you to remember all the ratios and their trig functions. So the first one we have here is SO. S stands for sine. The O stands for opposite, meaning the opposite side. And the H stands for hypotenuse. So when we're looking at the sine of theta, sine of a certain angle is equal to the opposite side divided by the hypotenuse. Ca, so ca goes with cosine, C goes with cosine. A stands for adjacent side. And H also stands for hypotenuse. So here, when we're talking about the cosine of an angle, its ratio is the adjacent side divided by the hypotenuse. Last but not least, we have TOA, which stands for tangent, which is going to have a ratio of opposite side over adjacent side. And that makes up our third ratio. Now, another way to kind of help remember your acronym, I write it a little differently sometimes. You can also write the acronym as a capital S, little h over top of each other to help you remember the opposite of our hypotenuse. Capital C, A over H. Capital T, O over A. You'll see that I rewrite this acronym repeatedly on top of every worksheet that we work on to help us remember the acronym and remember the ratios. So let's look at our first example here at the bottom of the sheet. We're supposed to state the ratio of the following, to find the following ratios of this triangle, which is given over here to the right, triangle ABC. The first thing that you're going to recognize is when we have to find the ratios, we have to know the opposite, adjacent, and hypotenuse of a right triangle. Obviously, we're going to label our sides. So the side that is across from the right angle, that's my hypotenuse, AB. The side that's next to the right angle here depends on which angle I'm standing at. So we need to find all three sides to figure out, to find our ratios. So if you have two sides and you find the third, you're going to use that Pythagorean theorem to find the missing piece. So hypotenuse squared is equal to the leg squared plus the unknown leg squared. 25 squared is 625. 7 squared is 49. When I subtract 49 from both sides, I get 576. And if I'm solving for the length of BC, I need to go ahead and square root, or undo the square with the square root. And the square root of 576 is a perfect square, and that's going to be 24. So the length of BC is 24. Now I know all three sides. So the first part, questions 1 through 3, they're asking for the sine, cosine, and tangent at angle B. So the first thing I want to identify is if I'm standing at angle B, I need to identify the sides that would be the hypotenuse. I would need to identify the side that's opposite of angle B, which would be CA. We'll denote with the letter O. And the side adjacent, not the hypotenuse, would be side BC. So once I know my sides as hypotenuse, opposite, and adjacent, then I'm going to go ahead and set up my ratios. Sine is opposite over hypotenuse, so opposite would be 7 divided by the hypotenuse 25. Cosine would be adjacent over hypotenuse, so the adjacent side is 24 divided by the hypotenuse 25. And tangent is opposite over adjacent, meaning that I'm going to do 7 divided by 24 for that ratio. Now the values kind of change here a little bit, but when we're looking at the sine, cosine, tangent at angle A, I've now changed my point of reference down here to angle A, which the hypotenuse is still the hypotenuse no matter where you're standing in terms of your acute angle, but the adjacent side for angle B now becomes the opposite side for angle A. The opposite side for angle B now becomes the adjacent side for angle A. So when I'm looking for sine, I'm looking for the blue opposite over hypotenuse, which would be 24 over 25, which actually is the same thing as the cosine of B. Cosine of A would be adjacent over hypotenuse, so that would be 7 divided by 25, which is also equal to the sine of B. Tangent of A would be opposite over adjacent, so that would be 24 over 7, which that ratio is actually reciprocal of the tangent at angle B. So that's our first example of setting up the ratios. When you're ready, you can go ahead and turn to the next page. And we're actually going to go ahead and look at some examples of finding missing sides using trigonometry. So to find the missing variable and round to the nearest tenth, we're going to follow some certain steps using our calculator. The first thing that we want to do when we pull up our graphing calculator, when we open up our calculator is we want to make sure that our calculator is in degree mode. That's very important in this class. Whenever you get ready for your SOL or you're taking a test, make sure your calculator is in degree mode. So I'm going to open up my calculator here on the screen. And you see a large screen here to kind of see what I'm going to do. What I want you to do to put it in degree mode is to hit second and then hit the mode button, which is right next to it. I'm sorry, that will quit. I just want to hit the mode button, which will take me to a list of settings that I can change. And I want to make sure that the fourth line down, the degree button is highlighted dark. If you open up mode and radians is blacked out, you want to make sure that you go ahead and scroll down to radian, click right once over to degree, and you want to make sure once it's flashing degree, hit enter and highlight degree mode. When you get out of this, you'll be able to see that up in the top of your screen, you'll see a degree symbol right here. It's very important that you check and make sure your calculator is in degree mode so that you can answer these questions correctly. So now in our notes, once we're in degree mode, we're going to go ahead and label our parts of our triangle, but we're going to label them as opposite, adjacent, and hypotenuse. So when I'm standing here at angle 12, what side would be opposite? That would be over here. The side adjacent would be the one next to it, and the side opposite the right angle is the hypotenuse. Once I do that, I want to go ahead and I want to set up the proportion. I'm going to determine the trig function that I want. I'm going to determine my trig function based off of the values that I know or want to have. So when I look at this problem here in the second step, I want to find x, and that's the adjacent side. I know the hypotenuse is 18, so I'm going to use the fact that the adjacent side is what I want to find, and the hypotenuse is what I know. So if I use adjacent and hypotenuse, I have to remember my acronym, SOHCA, TOA, and I'm going to pick the ratio that includes the adjacent and hypotenuse side. The ratio that I want to choose here is CA, which stands for cosine of a given angle, in this case 12 degrees, is equal to the adjacent side, x, over the hypotenuse side, 18. To solve for x in this equation, I'm going to go ahead and solve using cross multiplication. So I'm going to go ahead and multiply both sides by 18. And then that gives me the value of x being equal to 18 times the cosine of 12 degrees. At this point, we're going to have to use our calculator to answer this question. So opening up our calculator, we're going to go ahead and take 18, and we're going to multiply it by the cosine, which right above the 8, if I go 2 spaces up, that's my COS or cosine button. Cosine of 12 degrees, close parenthesis. When I enter that, I get a value of 17.60665681. We'll round that to the nearest tenth, so that'll be 17.6. In example 2, we're going to follow those exact same steps. Let's go ahead and label our sides based off the angle they give me in this right triangle. This would be opposite of 37. This would be adjacent. And once I see O and A, that tells me the trig function that I want to use, opposite over adjacent. So tangent is what the T stands for. Tangent of 37 degrees is going to be equal to the opposite side 10 over the adjacent side x. To solve for this, I'm going to have to cross multiply. Now remember, when I have a tangent of 37, that's just a number that I can divide by 1. And when I cross multiply, I'm going to multiply the tangent of 37 times x. And that's going to be equal to 10 times 1. To solve for x, I need to isolate x, so both sides I will divide by the tangent of 37 degrees. So in my calculator, I will go ahead and put in 10 divided by the tangent of 37 degrees. So looking at my calculator here, I'll go ahead and do 10 divided by the tangent next to cosine, tangent of 37 degrees, close parenthesis. When I do that, I get an x value of 13.27, which will round to 13.3. So using those two examples, go ahead and pause the video at this point and try the next 3 problems. Remember your steps: label, determine the trig function, set up the proportion, cross multiply, and then round to the nearest tenth. So after pausing the video, here we have some answers. For number 1, you got 13.6. For number 2, you get about 33. And for number 3, you get 12.2. If you did not get those answers, go ahead and check out the work. Remembering that the first thing you do in all 3 examples is you label your sides. You label your sides as opposite, adjacent, and hypotenuse. Since I have the opposite adjacent here, I use the opposite and hypotenuse here, and I have the adjacent and opposite here. For 1 and 3, I'll use tangent of that angle measure and set up the ratio. And for number 2, I'll use sine of 27 degrees to set up my ratio. Once I do that, I'm going to use my cross multiplication property and solve to isolate x. That is the end of our notes for 7.5 through 7.6. Make sure you try the practice problems in your note packet as well as your homework problems.